across Gujarat in domain of soft computing and wireless communication. So thank you, Professor Maulin Joseph, for joining with us. Now it is over to you.
Yeah, thank you, Professor Amit, for giving kind introduction. Say, friends, uh, I need to just confirm. I have got around 45, 50 minutes or some more time.
You can have up to 6 or maybe up to 6:05, 6:10. Okay.
Okay, fine, fine. I shall try to adhere the timings, but by chance, say if I exceed because of the inherent teaching nature, so please just stop me. Correct?
Okay.
So let me just go to the slide. I think that slide is visible. Correct? Introduction slide is
Yes,
visible.
yes,
To all.
it is visible.
Okay, friends. So this is the typical thing that we are today to look for. Title is known to you. Say we are talking about some insulin management in a particular human who has got type 1 diabetes. So if we look at the cycle from food to the regulation, then first of all, once we eat, the carbohydrates that is been intaken, that is getting converted into glucose, and that particular glucose enters on bloodstream. Once that glucose has entered the bloodstream, glucose signals the pancreas to release the insulin. In turn, this insulin will help. So you can see here that insulin that is getting this glucose to the blood streams in our body, and once it reaches there, it reaches into the cells. Glucose either is getting consumed immediately or it is being stored in terms of a glycogen in the liver for the futuristic use. Now, moving glucose out of the blood and into the cell, insulin helps to keep blood sugar levels within the healthy range. Now, if this is not being followed, then we need to take care of, think slide is not getting changed. Hello.
Yes. एक minute.
Something need to be done from my side.
No, 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 no. You are at introduction slide. Yes.
But yeah, okay, okay. Now it has come. So diabetic is in general been known as a chronic metabolic disorder. And if you see the causes for the T1 diabetes, so it is due to the autoimmune reactions. So body immune system mistakenly targets the and destroys the beta cells which are available in pancreas and that are uh, uh, origin to generate the insulin in the body. Because of that, with fewer or no beta cells being produced, body produces no insulin. And hence, the essential uh, 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 quantity of insulin, which is responsible for moving glucose from the bloodstream to the cell, gets interrupted. And without this insulin, uh, we lead to the so something called as a high blood sugar levels. Something is fishy, not helping me to change the slide. Okay, fine. Now it is over. So some key symptoms for the type 1 diabetes are either the patient can have an increased thirst or frequent urination, extreme hunger, unexplained weight loss, fatigue, tiredness, blurry vision, and increased irritability. And hence, because of these all features, friends, early detection and the controlling of the diabetes is must required. If we talk about that uh, type 1 itself, then it can, in principle, can occur at any age, but normally it happens with the adolescents or the young age, that is in between around the age of 19. Risk factor will again come into the next slide, so I am omitting here. Type 1 diabetes cannot be prevented. So that is the some drawback, but it can be effectively managed either the insulin therapy, in which the insulin salts are being inserted using the insulin pumps. Second one, that is the blood sugar monitoring. So we need to check the blood sugar level in a patient regularly. The third option is that we should start living the healthy lifestyle, which is little difficult these days for all of us. That includes me also. So if we want to compare the type 1 and type 2, because the diabetes are of two types. So uh, if we talk about the onset, then occurrence of the T1 is sudden, while T2 is gradual. As said earlier, that age at which T1 occurs, it is mostly at the young. It can happen later, but mostly it will happen in the young age. T2 normally gets the 40s. Uh, so in T1, person may be thin or normal. And in T2, it would be often obesity. Ketoacidosis. So that is very common in T1. So that is the increased acidic level in a human body, and that is very common in T1 and little dangerous also. While in T2, that is rarely seen. Endogenous insulin in T1 is low or many times absent totally also. In T2, it is normal case, it is normal. It may be increased or decreased depending upon not many other parameters. Antibodies which is generated in the human body usually be present in T1. In T2, it is absent. Damaging the pancreas is, it is in the case of T1, now in the case of T2. And for the survival, it is in T1, insulin is must. For T2, it is required, but not, it will not, that lacuna will not run to the problem of a human. If you see the International Diabetic Federation figures, so these are the latest figures that I had fetched sometimes back. So you can see that currently around 589 million people are suffering from diabetes in a way or another. And the figure is likely to increase up to 643 millions into 2030, and 245 it will grow up to the 783. So this is the problem that requires some early detection and some diagnosis as well. The problem that currently I am working with my student, and we found some lacuna to address the problem. So uh, currently the methods which are being used, say incidentally that group at MIT also closely work in this fashion, and thanks to them that device, that is a non-invasive measurement device, that is and we also use. So current traditional way of measuring glucose, blood glucose is the invasive one, in which you need to actually print your body. So it is little difficult. Traditional methods normally are restricted up to the measurements level only. Only few of them are concentrating about the forecast, and only few of them are talking about the control picture at the same time. So the gap is the again that what sort of insulin dosage that one should take. There are two phenomena coming out that we shall take it the later of this one. So whether we should take it continuously, whether it should be taken as a increment stage or what. So that we shall discuss. So that is the gap. And then incidentally, people do not talk about the auto insulin injection. So that is again some of the drawback. If we look at the generalized diagram, so we have tried to make it generalized that what people can contribute in this of the healthcare. So one is that we should be able to measure the continuous blood glucose. Once it is available, we should be able to make the data pre-processing, and then we should use the some learning model in order to measure glucose. Whatever our measurement methods are there, obviously we need to have performance evaluation to check that whether our measurement methods are correct or not. Once we are able to measure the blood glucose as a continuous instant, we should be able to forecast it. And again, performance evaluation can be done instant. Once the forecasting is available, measurement is also available, we have to go to the next step to calculate the insulin dosage and then to decide that how and at what instances we can give the insulin. Some open challenges are, oh, sorry, one is to study the multivariate features that affects the measurements and the forecasting of the glucose. Now, whenever we talk about the multivariate feature, we know that it is just like a multi-objective optimization problem. So, not many conflicting features, positive effect, negative effect, also come into picture. So, to neglect the negative ones and we need to take the advantage of the features that can help us to measure and forecast it correctly. This is an open challenge forever, and people are continuously working it. Then one has to concentrate about the physiological activity that affects this blood glucose monitoring. Then some efficient algorithms always welcome for this sort of studies. Models that takes the time series as an input and gives some forecasted output. Then altogether, the model different problem is that to make it personalized, because all the models that we train are supposed to be the very generalized one, but something that is very generalized cannot be applicable for the individual. So this is always an open challenge that generalized model converts to the someone's individual characteristics. Some standard data sets are available in literature. I may not go into the details, but the foremost is what we are talking about the group itself. Professor Amit Joshi is one of the members, Pratik and all. So it is an igloo data set uh, that considers the total 99 subjects. Uh, Input parameters are typically gender, age, weight, and three sensors, and it addresses type 1, type 2, and healthy data. Similarly, some prominent data set that what you see across and we have used studies the Ohio University data set. So Ohio T1D is for the 12 subjects. It is for 12 subjects, continuous glucose measurement done each and every 5 minutes. And then these are the parameters which are being looked for. Then PIMA dataset is there, SugarMed dataset, AB4CD, and likely so many datasets are there. About the architectural requirement, so deep learning, you know, has penetrated a lot in last couple of decades. So specifically, to be specifically after 2010. So people are using this architecture. So as mentioned here, the generalized thing is that there is an input layer, there is some output layer. Output may be either the prediction or the classification, and there may be one to n number of hidden layers in VGG 16 and VGG 19. You know that 16 and 19 respective hidden layers. I may not go into details of the deep neural networks because I am very sure that a person who is attending this FDP must have gone with the inner way of architectural details of neural network. So the advantage is that it can work with the unstructured data. Was the little lacuna in machine learning, and machine learning required some feature engineering before it can be given to some shallow networks. At the same time, that advantage of machine learning, that is the little disadvantage with the deep neural networks, that is the number of trainable parameters increase drastically, and couple of the more important problems which are written in the literature of the neural network, that is the vanishing gradient problem and the exploding gradient problem. Now, because of the lack of time, I may not be able to go into details, but vanishing, that means that your, with respect to time, given the inputs, your learning rate of the algorithm becomes too small. So that's a problem because your efforts that you put in does not give you fruitful results. exploding problem, that means with a very little effort, we are achieving a lots of changing in the variables or uh, design parameter change. So that is again another extreme. And if you are getting exploding gradient problem, then so researchers should get worried of. Convolution neural network is a standard architecture being run. So some of the layers does the feature extraction task, and the later some tasks does the classification task. So in the feature extraction part, so the repeated layers of convolution and max pooling, convolution and max pooling, and we know the details about the convolution. So convolution, I think that very shortly I can explain you that whatever your image size, that currently it is for the example 4x4, and that we are just trying to modify with the help of a technique. So here the signal is being shown as a 2:2. So signal effect is to modify the image in a little different sense. Uh, so as one way to achieve the given target or to extract the feature, so to mold it in a way so that we can extract the feature, and the operation would be like this. So if it is 4 by 4, so this kernel moves usually over the this yellow one. So blue one is the kernel. So yellow one has the expected region. It does the point by point multiplication. So 1 multiplied by 0 plus 0 multiplied by 1 plus minus 1 multiplied by minus 1. The net result would get some here. So once this exercise is done, 4 plus 4 image has got loaded here to 3 comes 3, and so and so on. This is just an example. Pooling layer, as we know that uh, in pooling, people generally do the max pooling, and uh, most purpose that is for the pooling, that is to link the data so that your deep learning method does not need to uh, go with the higher dimensional space whenever classification is being required for. So this is the fully connected layer. You all must be knowing that in fully connected layer, all input layer to the hidden or the output layer connections are always available. I'm not reading this convolution neural networks advantage limitations because they are known to you. Activation functions are very important parameters. So anywhere that whatever the non-linearity that we want to generate, that is what is highlighted in the last one. So it is been able to generate because of the activation function. So uh, normally W transpose X is a linear function, and we can make it pseudo linear with the help of the bias term which is been given. But the actual nonlinearity is that the subspace which we want to take the feature, it is actually been introduced by activation function. So there are various types of activation functions. I am sure that learners of the machine learning and the deep neural networks should have gone across these things. All have got their own advantage, disadvantage. Normally, for the deep neural network architecture, people go with the ReLU, that is a rectified linear unit, as an activation function. Loss function is very important because say that is the particular hint that drives us that whatever the error that we are committing with the current episode of the training, where we lack and what we need to improve. So loss function generally is measured in terms of the entropy. So entropy, so it's, I think that if you are fond of mathematics, then entropy is actually related to repeatability and the unit. Greater the entropy, later greater the variability of a given training or the point or the score, and then you can take. And entropy has got some sort of correlation with the expectation also, where the expectation you must be knowing it is summation of xi into pi. So pi is here that information xi is that it is associated with a given uh, 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 given point is of our interest. So That particular thing has given rise to this entropy, or in general as a cross entropy. So loss functions, others which people are using are the either the mean square or the mean function. Generally, people go with the mean square forms, in which first we find out that is pi minus y, then we split it, then we come it over to one, and then we take the average. So that is exactly the way from in to out, and square and then mean. This is the process. As far as the blood glucose measurement is concerned, we have divided largely into the three parts: data pre-processing, parameter initialization, and optimizer selection. So in pre-processing, there are various ways to process the pre-processing. Subtraction is one of the way. In general, people go with this min max scalar technique. So x is unknown. So if we take x is equal to x min, so either given your all data entry in a column, so if x takes x min, then the output would be 0. If incidentally the x takes the another extreme, that is x max, then it would be x max minus x min divided by x max minus x min. So that would be 1. So pre-processing like this, actually it's a great boon to the learning networks, because that makes the data normalized, and that removes the unnecessary bias if moved in the raw data that we are supplying to the neural networks. With the parameter initialization, network must be well initialized. There are ways of initialization. I'm not going into details. Most of the literature says that if you are not very sure, obviously you go with some random initialization so that you can get rid of any biased error out of it. For the optimizer, again, the various functions are available, and these are few more. But the again that literature, if you see in any domain, people are generally found this num optimizers. So this is the equation. Because of the lack of time, again I am not going with the mathematical details of these equations, else we can discuss. For the blood glucose measurement implementation using fully connected network, uh, in our implementation, as I mentioned, that we used the dataset that was created by MNIT group. That is a blue dataset with the 99 subjects, 55 males and 45 women, and the features gender, age, height, and three sensor data. So training was for the 70 subjects we selected arbitrarily, and testing was done on the 26 subjects. Optimizer Adam, activation function ReLU, loss function measured was the mean square error, and matrices matrix that was used, that is RMSE, and that is already published paper by Sri Pratik Jain and group in 2019 in Consumer Society. Implementation using the fully connected layer. So if you see that there were 6 inputs, gender, height, and three sensor data. So 6 inputs, then eventually we have put some hidden layers, 1 to 10, 1 to 10, and then we have taken the output in each. So this is the detailed bifurcation for someone who is novice for the uh, computation of the learnable parameters. So it is that very simple thing. If it is m dash n dash l network, then it would be m cross n plus n cross n plus m plus n plus n. So that's the thing that that input multiplied by the neurons, input and the hidden layer, and then this will need to be added, and this throughout, including the list output layer. So in our case, total parameters became 1181. Evaluation parameters, this many options were there. So we have evaluated our work with the same thing. So you can see here that 18 is the which was done by the proposer, that is Pratik Jain. with the three sensor data. We also took the three sensor data, 6 10, but our architecture and our independent and parameter adjustment was also little different. So we could include nearly 1.7% to earlier 7.32. But no, disrespect for the data set was used from the paper number 18 itself. Correct. So this is our work that we did, myself along with my PhD student, Ketan Lal. All simulations are done by Ketan. So in implementation, you can see the reference blood glucose and the predicted blood glucose. Well, except some extreme changes, that more or less it is able to predict the reference ones. This is a standard way of analyzing things, and this is known as CEGA, that is a Clark error grid analysis. So again, depending upon the accuracy that you get, it is being divided. So you can see that something like one is coming out. So it is the zone A. But if you predicted outputs are within the 10, 20, less than 20% from the given values, then you will feel. If not there, if it is, if your readings are between the 20 to 60% accuracies, then you are in the zone B. Zone C are these levels. So it is between the which are given, and then B and E are respectively bad figures. Ideal way that it should be either in A or the B regions. Similar studies in healthcare also suggest that mostly your readings should be in A or B. Luckily, in our case, we could get almost all things in region A. Now, friends, at this juncture, before I move on, uh, uh, I would like to point out that the explainable AI has driven attention in these days because inherent lacuna with the traditional learning model. So, AI has been used in healthcare for many times, but the main reason that is going for or to quest for the XAI, that is the medical experts generally distrust the black box model. So unless and until the model is able to give the justice, they people don't accept it. So that's a lacuna. So in XAI, what people generally do, uh, uh, with the new data, it is been bifurcated into two things. So model is being trained, some predictions are being made, and evaluations are made. So once that is done, the same model is being used for the prediction, some representations being there, and whatever the predictions are there are being explained by some explainable AI models, and those models two that we have used in our uh, experimentations are, one is the line, that is a local interpretable model, axonistic explanations, and the second one is a stacking model, SHAPELY additive model. So SH A and P. So that makes SAP. In the line model, we are looking for the generally the local neighborhood. We want the model to be interpretable. It has to be agnostic, that is applicable everywhere, and explanations are required. So you see this example here. Some of the parameters that may define some healthy patients as well as for the unhealthy patients. This may be for the any applications you can do. So you can say that this uh, one color that shows that healthy patients data, and the second one is very from very for unhealthy data. So you just see that this arrow with features, just that body weight is almost same, just a slight change in the exercise duration, and then the person being considered as a from healthy to the unhealthy one. Similarly, you can see here that In that particular case, that exercise durations are being same, but just a change in the body weight that makes the bifurcation from again from healthy to the doing what is a unhealthy one. So that is the need. That, what are the reasons? And in that deep neural networks to explain that the person needs to make different change in the behavior. Maybe in this particular change, you may need to just increase the exercise duration. In this particular case, that person need to be to become healthy, need to reduce the body weight, and so forth. So such sort of explanation is needed uh, for the same. Intuition behind the line is very simple. So it is just like your that weighted average model. X1, X2, X3 are supposed to be the different features which are affecting the to derive the output this. And these are the weight factors W1, W2, and W3. So we can say that I think you must be familiar with partial derivatives. So partial derivative of this dou y by dou x1 would be the w1. So that is that sensitivity with respect to x1. Dou y by dou x2 would give you the sensitivity with respect to x2 and this being denominated w2 and so forth. So what we need to do that we need to explain that whenever this is the global model, the global model will not be able to explain where the corrections are required. So what we do that we go for the local interpretability. So this small region I have made it so here as so this uh, dotted line is the prediction and this blue line is the actual one. So you can see that this is like just a plain of it. So uh, to the left is the uh, healthy data, to the right is the healthy data, and then this particular data is under the gradient set. That should be done. So what we do that this area we want little more inquiry is being grown. So when it is being grown, so we will be able to explain us that how much deviation from well to well we need to different. So friends, say if you are not able to get, say, I just try to explain you in a couple of slides. If you are not getting this explainable AI, absolutely fine. Don't worry. So this not understanding this explainable AI will not offer your any implementation. So still you have to give it into Python and Python will give you some answers like this. So the final answer would be like this. Your age is 1 parameter, BMI is 1 parameter. This is and these are the importance. The importance of the respective parameters in diagnosis the person is a healthy or unhealthy one. So that is that. Uh, this is something that I told you that we need to grow the region and then some high value or the low value that will uh, decide what to do and what not to. And the probability of this one. So we'll discuss shortly the kernel function in this second line model. So that would be helpful to you to make the more decisions. Now, this is one more way to look at it. Glucose for the current patient, if the glucose level is 98, so that negatively works to detect the diabetes because the glucose level, if you can see here, 100 is that. So what we will do, that this may be the designer's problem, but the designer kept it at 100 for the given patient. It can be less than 100. So it actually goes the other way. It indicates that person is not supposed to be with have a diabetes. If the person's age, which is given as 43, so you can see that the threshold is kept at 40. So, getting age 43 has positively contributed to detect to detect the person who has got diabetes. Similarly, you can see with the blood pressure, insulin, and some pregnancy effect. So here you can include the glucose level, insulin level, pregnancy indicators are actually helping us for the no diabetic detection, while the risk factors are actually saying that they are advocating that the thresholds have crossed and hence the person is supposed to get a diabetes, which is actually there. So orange spots are the going in synergy with the conclusion we made. The person is blue ones saying the opposite things. Let us proceed further. So another explanation that what you can go here is the original image. Actually, we are talking about the partial instances. In a couple of slides back, you have seen that the color points that I try to explore more. So what we are doing that whatever the original image is there, if we are taking a point of view. So one part is the and that randomly being selected. So another subset may take this part, another subset may take this part. Now you can see that this particular instance it helps us to take that, say this is actually the different example that I have included to make it more simpler for understanding. So instances actually help us to make some more concrete conclusions. So more the instances we extract, more the probability that are being associated with it, and more explanation we will be able to create. So here you can say that only the detection of this particular calculator is the main reason to detect that the given image is of fraud. Is fraud. Yes? So that is how this explainable AI works in this domain. Uh, this is again the same bifurcation that one that looks with the probability of 0.54. Another parameter that it actually resembles that this particular some your snooker balls. It may be like your balloon also. So that probability that uh, with this probability it is frog, with this probability it is something other, and with this probability it is something other. In the line, this is something that you need to look at. So what is that? So this is the function that you are trying to uh, uh, optimize. X are the predicted instances. Now what we are doing, we are trying to find minimize the loss function. Now there are two parts. One is the direct one, and the second one is the energy part. I shall not discuss about this because it is actually associated with little regularization. The complexity of a model is closely related to the regularization we can offer to the deep neural network modules. So more complex model, you are less likely to have a lesser loss function. Your loss function actually gets worsened with the complexity of a model. And that is why I submit that you should look for the lightweight models. Another important thing that is directly affecting that is that this is something that is the given complex model, just like that global picture you are able to see. G is that linearized part. So it's a simple or the surrogate model, and that is the this particular part. Then, we are looking for the some variance of input space that we are looking for, and then uh, data frame at any given instant will look like this, and ultimately will help us to solve the problem using the line model. So that is one. That is uh, another way to interpret it. So this is that surrogate model that is trying to mimic this. So this shows the actually this is the weighted average. And weighted average It's an exponential form. So I think you must have learned about the errors. Those who are with the closely associated with computer science, the students will be able to with the Gaussian function, e raised to minus something. So it's like a RBF function. So it takes some mean value and then takes a Bell sort of function. So as you move away from it, your chances of affecting the decision making keeps on diminishing. So that's the meaning of that. We have already discussed. Shapley model, I shall discuss very quickly. So in Shapley model that uh, the person is either to be diagnosed as a diabetic or the non-diabetic, and then this value parameter will be affecting in student creation of diabetic parents. So because the parents are directly can give you the diabetes and then calorific intake that you are taking. So suppose that a person has got diagnosed as a diabetic. Then what is the contribution of this? Are they all contributing equally? If not equally, then what should be contributing what? So it is exactly being answered as a Shapley model. So in Shapley model, what we do, I can just explain in a couple of slides on it. So then we consider the different subsets. So I think again in mathematics you must have heard about the marginal probability. So it is just like that. Say all the subsets of this particular sample space. So you know that if two values are there, then 2 raised to 5, 32 subsets will be at least will be there during the multiplication. So in all subsets where the age is present, that will show us the marginal contribution of the age. So here we are advocating to find out the importance of the age parameter. So, to understand Shapley, for a given patient, suppose that uh, five parameters are known and they have included that the person is take how much each parameter is contributing. Answering that, that is understanding of this Shapley model. So you can see that in one of the model, one of the subset, these two values have been cancelled, but we cannot reduce the cardinality because you know that otherwise your neural network, which is being made for the fixed cardinality as an input, will not work at all. So you need to replace this particular value with some small random values. So that the presence is there, but you are not actually counting them for the implication. So whenever the age subset is there, age comes into the subset, you can go give, take the implication of the do the implicit and that will give you that what is the effect of age in your decision making. This is little complex mathematical slide, but it is very actually easy to understand. So what you can see here, that we were talking about the age as a parameter. So that second part, that is the 15% f of h's, zero is your height. That is something that is in the essence of age. So 60 minus 15%, that subtraction will give you the importance of age. So without the age, your accuracy, model accuracy for this prediction being diabetic was 15%. With the inclusion of age, that has got now increased to 60. So 60 minus 15, that is the importance of age as a field. Good thing, that is this. Now, see, this looks little weird, but it is just like a finding out the BCM. So you have what is the formula for finding out the combinations? So it is just like that. Say, if your n is the total number and uh, z prime is your uh, parameter is being present. So you are just trying to find out the marginal data. So if this value very important, then automatically this weight factor would be more. If it is not so critical, then automatically this weight factor will go to low. And this is how the Shapley model helps us to diagnose further. Now, Once this is done, this paper that we could publish in one of CLC-based publications as a book chapter. Now onwards, the things are very simple. So let us discuss about the blood glucose measurement using the three sensors. I think that the MSP group originally pioneered here. So we have taken the group for the 96. I think some three samples were somehow discarded. This is a actually runs behind this everything. So there are forgiveness factor, or the you can say that remembrance factor, and then flexibility. So they both work in tandem to decide the effect of this arima. What we did that uh, we actually we divided this particular thing into 11 different classes. Now it was just again the quiz that I was earlier talking. That going back from the deep neural network to the shallow network, lightweight architecture networks. So it is just like that. Say, uh, if you cannot solve the problem with machine learning algorithm, the biggest problem is due to the complexity of nonlinear mapping between input and output. So in a given, that is the glucose range starting from around 70 to maybe 250 to 70, maybe 300. All class blood VG range you cannot accommodate. So what we do that we can use SVM or in a random forest algorithm to pre-classify it. Given data is closely resembles to which, and then in particular, that particular range, once the data has come, you go the prediction using the sub model only. So instead of doing with the entire complexity, first you remove the complexity, it is going to make you say to knows with this particular number so many different features possible issues that obviously so within the space would get shrink to a lot. So that's the main idea here. So using that, we did the pre-processing. Once the pre-processing using this regression model 1 to 11 was possible, this is the range which are being written. So this is the implementation setup that we had done. The programming was in Python and RMSC cross-validation using 10.4. And this is what we could get. For 96 people, that adolescent persons, that is between the age of 6 to around maximum is 15, that is being taken. This group range were made, and then average deviation from we did the data augmentation also. So data augmentation techniques, these are well defined in literature. So when you have not got the sufficient data to train your model, so somehow you need to augment your images. And once the data augmentation is there, then you need to just subdivide it into the training data and testing data. So for this particular experimentation, we had 6, 8, 9, 7 samples. Pre-classify results with the random forest gave us the accuracy of 97.75 with the testing accuracy around 97. So this was with the three sensor data, just like what was done for the same one. For the igloo data set, we got with the random forest compared to linear regression SVR. This is what we got the accuracy of RMSE of 1.07. Final result of this distributed architecture random forest was our conclusion. Average uh, variation was 15.14 and detection accuracy was 97. Uh, the data given by MNIT group, we further used it for the single sensor. Again, the sensor was made by the same group. We just did our experimentations on the same. So we performed our experimentation at a Valsad. Valsad is one of the districts in the Gujarat region. So this is the details and creation of data sets details. So this when data collected again that as a normal routine practice, consent from the all the subjects who undergone with this test, the consents were given, and then we selected these 13 features. And then we divided here into the 8 groups, and then for our 8 groups, again the training testing samples. This is the architecture. So we first, whatever the data is for the training, we pre-classify it, and then we train the model. Once the model is trained, we just use it. Now in the testing set, we just classify that this particular data training need to be classified in this one. So if classification class is one, then only one first model will do it, and result will show us that with the random forest, we could achieve the accuracy which is even better than the with the three sensor data. So now the accuracy has jumped to 98.26. So these were the final results. This was the publication that we could do out of this one. The next thing that is required, that is the forecasting. Now, forecasting, you know that RNN are the best candidates. Apart from RNN, you can use STM networks, or there are some other variants of RNNs are also there. Standard got its own problem, but again, that we can fix. Evaluation parameter we selected at this one. And this particular thing we performed on the Ohio data set first. So Ohio T1, that is comprising of a 12 patient data. I think I mentioned it earlier in the results, and total training samples instance which were extracted out of that continuous data was 1,34,000, and 31,000 samples we tested it. We did data pre-processing. So you can see that here the blood glucose measurements is continuous. Then carbohydrate intake is at some particular instance, and insulin intake is just before or at the same time of the uh, carbohydrate intake. So that we can fix. Again, so in any forecasting model, inputs would be obviously the glucose level, insulin level, in the meal that rather the in the meal the carbohydrate level that we are intend to take. We need to remove the fill the missing values, then point field and input field, and then align the data, which are the must required things. And after interpolation, we could make it continuous so that the fair comparisons can be done. We used these many models for the forecasting: traditional CNN, simple RNN, LSTM, and MLR. And these are the features that I already, this is just a summary, what I already uttered. What we did that we used the past 6 samples to forecast the future. And we forecasted the future for the 15 minute, 50 minute, and 60 minutes. That was our horizon. And you will be able to see that these are the RNC we could see. Now you will get surprised that actually here MLR outperforms the C. So normally we believe that MLR should not perform well because the rates are very complicated and good model. But in our experiments, we found that MLR proved to be the best. So my suggestion would be to all the participants, whenever you use it, test the simple models also. Maybe that the simple model may work for you. And if the simple techniques works, you actually need not to go for the complicated model to make your life miserable. And we do for that. Another way variant you can work for that, we can measure the difference in the glucose level at T instant and T plus W. And then this is a standard paper. I have given the reference. Using the same, we can forecast it. Again, you can see that uh, model is able to forecast the things well, reasonably well in the given range. Again, you can see that STM is good, CNN is also good, and CLR is also not bad. So my submission again would be that always test the simpler model because of this. So here again, the similar results are there. I'm just keeping it. This is the complexity. You can see that For CNN, the total learnable parameters were 10,700 also. For RNN, 3,500. LSTM, 36,000. And our standard frame, that is multilinear regression, we could achieve that accuracy with only 19 learnable parameters. So that endorses the fact. We did the experimentation with the again with the help of our friends at MNIT Jaipur. So it is the UA Padova T1 simulator. So it is for the virtual patients experimentations. 33 virtual subjects data is available. We did it for the patients. This particular simulator is well known and even that accepted by the FDA also. So it can be there for some meals as a reference given. Meal time may be 8 a.m., 12 noon rather, 16 and 20. So 8 evening we are talking about. Some base meals we can take. I'm talking about the only amount of carbohydrate. Others actually do not affect a lot for this prediction. So 35, 45, 1 and 50 max meals again. And then we generated different subsets based on this incremental and increase. So 35, 45, 1 and 50, 35, 45, 1 and then 60. And similarly, we made lots of subsets. So total 1344 scenarios were generated for each patient, total 11 patients. For that, we kept 8 as for the training one, 3 for the testing one, and this is what we could get. So again, you can see that for the 15 minutes prediction, RNSE is 3.06. For MLR, for LSTM, that is 7.37. For 30 minutes, it is 6.24, 7.76, and so on and so forth. So we can say that for 15 minutes, that we can even use it for the 30 minutes prediction. So that gives you the flexibility to decide the dosage of the insulin where the patients need to be given. It can be at the time of taking the food, it can be before half an hour, it can be before 1 hour, it can be throughout the day. So people are experimenting in different ways. Uh, To compute this insulin dosage, actually, I think Professor Amit, I've got 5 more minutes. Hello. Okay, fine. So I shall conclude very soon. So some literature available models are there. I'm not going because the slides anyway I'm supposed to leave with you. All the slides would be there. It is meant for you people only. So some of the paper talked about the personalization because say one diabetic person's personal characteristic may be different than the another one. So what we need to do that we need to train the generalized model and then we need to make it personalized. Again, then there are supposed to be two variants. Either it is supposed to be bolus. So bolus is that at the time of meal, whatever that insulin you take, that is said to be the bolus one, and the basal that is that something that effect keep its effects for the longer. So that is to be done. So looking at we have also done. Unfortunately, the art paper also is in the advanced stage in some journal. So I'm not sharing you final results, but uh, you can look at this. So it is individual to the general body characteristic. So one is the carbohydrate level. So the carbohydrate that you take more ultimately drives you to take some more insulin. CR is the base rate. So because as I told you, that everyone's body is different, correct? So that insulin to carbohydrate ratio is also different. So for a given insulin ratio, you just see here with the unit to unit, gram per gram to unit. So gram will get cancelled and you will get in terms of unit. So that much unit of insulin you need to take. So more carbohydrate for a given CR, you need to take more insulin. Again, this is that uh, correction factor. So we can target a given insulin level in a body of a patient. So that is your 16. So the larger the difference between current glucose level and the targeted level for a given patient, it is again a normalization factor, a rationalization factor. So if both are same, then obviously that if your current level is the targeted one, then you need not to take anything. So that is for which it is done. Now it is IOB stands for onboard. So that is a correcting factor that you need to deduct because the earlier insulin that you have already taken and the residue effect of that insulin, it is still there in your body. So if you assume that currently no insulin is present in T1 diabetic patient, then actually it is present because of the earlier dosage that you have taken. So that is to be considered for this one. So this 1, 2, and 3 parameters are important for this one. So 1 to 10 parameters been fixed, and with that particular thing, uh, we have actually proposed the models, and our results are also available. As I told you, because of some technical glitches, our commitment to some other agencies, these results I am not allowed to public, but except I have given you. I think these are the references that anyone interested candidate can go with the insulin management. And for in general, whatever I have talked, these are the references. So our strategy is not to take credit of any researcher who has got all hard work to enable us to present our work. So these are all references. Yeah, I'm done with my lecture, friends. Uh,
Okay,
Admiralty
okay.
team, please, I am at your disposal. If
Yeah,
further
yeah. Thank you,
lectures, then
Professor Maulin, for a wonderful session. Now, we invite the question from a participant. They can write down at chat box. Okay, then we can read out.
yes, friends, if I am able to ignite something,
एक आया लग
then
रहा है.
then
Okay.
I would feel that it is one.
Yes, if any question, then please do type at the chat box. So we
So either
will.
the lecture was so boring that you lost your concentration and there are no questions. I take it always in a positive way. So my question was that much insightful that you learned everything, like what I think Pooja Chaudhary has written. Thanks, Pooja. Yeah. So on some other platform, so now I'm killing some others' time. So
Difference between literature review and research review.
difference between the literature review and the research gap. Uh, Literature review is something that you come across while searching something. Research gap is something that you identify. It is your essence or extract that you have extracted out of all hard work done for the research. Literature review. So research gap is your conclusion after going through the literature survey. I think I have made the clarity.
Okay.
Right?
Okay. Uh, it seems that there is no further question right now. I think already all the participants have a email ID of all the experts. So if you want,
So
then
if I can help anyone, I'll be uh, I'll feel good. Yeah.
okay. Okay. Thank you, Professor Maulin, for joining with us. Thank you for a
So
wonderful
should I
session.
exit my session now?
Yes, 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 yes. Please, please. Okay. So, participants, with this, we are ending up our first session. We will take Possibly 5 minute break, and we will start at 6:16 again. So Deepak Ranjan sir is already waiting. So I hope, sir, you don't mind for a 5 minute break. Deepak sir.
Yes, sir, absolutely. No problem.
Okay. So we will meet at 6:16, sir. Okay.